Good
Okay.
morning, everyone.
Morning, everyone. Nice to see you here again. Okay.
Thank you. Yeah, good to see you all.
Dinky, let's give ample time, the students ample time to discuss and to connect for their homework also. So
Okay, sure.
thank you so much.
So, Dr. Kitain, will we have another breakout session so that they can discuss? Or...
Yes.
Okay. So, thank you.
So I'm going to separate them into 5 groups again, according to their groupings. Okay. I will make an announcement first. Make an announcement regarding their homework and also some. Would I also like to share the link, the Google Drive link for the Zoom, yeah, for the recordings. 12:48. Again, some of the students couldn't attend because of vaccination. Some of them are taking like second dose COVID-19. How is the situation in the Philippines?
Yeah, I think we're still continuing with the vaccinations. Though, yeah, I think the Moderna only came in recently. So,
I see.
I think in NCR, there's more proportion of those getting vaccinated, but maybe in the provinces, not yet.
I see. How about in Slovenia, Dr. City? How is the situation?
The situation, recently we have like a Moderna.
Moderna.
Yes. But for students, ITS students, Sinovac.
We administer Moderna to our students, but if you go to a hospital or a clinic, they're going to give you Pfizer vaccines. They said Moderna is even more effective than Pfizer. We still have 5 minutes. Yeah.
Yes.
We'll start the class.
Professor Kitain, maybe this time I can how to say, give announcement and then you can add some information, maybe like that.
Yes, please, Dr. So please do make the announcement first and then. Okay. To our Japanese students, if you can change your name to Romaji.
I think to all students,
yeah.
Better you write your name and then your university. KU from Kumamoto University, ITS, UTP, or Chula, something like that. So we can know how many students from UTP, from Kumamoto, from ITS, etc. How about like that, Professor Kitain?
Yes, Dr. Siti, that's a very good suggestion. So we ask our students to also write their university, their affiliation. So your university and your name for our Japanese students in Roman alphabet, in Romaji.
Another 2 minutes.
Oh, yes. So, Dr. Siti, we
Yes.
will start with your announcement first. Okay.
Okay.
Followed.
We start now, Professor Kitain.
In about 2 minutes, Dr. Siti.
To all students, please write your affiliation and then your name.
Nihonjin no gakusei desu keredo onegai ga arimasu. Namae o romaji ni henkou shite kudasai. Daigaku mo kakeba wakariasui to omoimasu. だから経由でもいいんですが、熊本 University 経由と名前。で、名前はローマ字でお願いします。All right.
Oh,
So
yes.
it's already 12:54.
The bell ringing.
Yeah. We will start with some announcements from Dr. Siti. Yes, Dr. Siti, please.
Okay, thank you, Professor Kitain. Good morning to Professor Kitain, Dean Aviso, Kumamoto University students, ITS students, UTP students, Chulalongkorn University students. This week, Professor Aviso will continue the material related to optimization. Before Professor Aviso will explain about optimization, please let me share some information regarding group homework that we already post via Moodle for Kumamoto University and also via my ITS classroom for ITS students. In my ITS classroom, we already post that please try to contact your group mates to discuss your group homework. Okay, and then after you can discuss after you contact your group mates from Kumamoto University, ITS student. You may also include other auditing students from UTP, from Chulalongkorn, etc., something like that. And then please do the following. First, discuss any product that you like and identify the main component of the product. Okay. The second, please figure out the supply chain or life cycle phases and the possible environmental impact at each phase. So you have two things you have to discuss, okay? And then later on, you have to figure out the supply chain that already explained by Professor Aviso in the second week. And then please submit your report. It's a free format. You can develop your own format. We not provide a default format in here. So please use your free format and submit it no later than October 22. Okay, so for one group, you have to submit one home group homework. Okay, and then for ITS student, you can submit through my ITS classroom. And then for Kumamoto student, you can submit through Moodle. Okay, no later than October 22. You have more announcement, Professor Kitain?
Yes, Dr. Siti, thank you very much for explaining the homework and its addition to our students. To our Kumamoto University students, let me share to you the Moodle page once again, all right? So here is the Moodle page. I posted here a Google Drive link. If you would like to recall the contents of each lecture, you may want to watch it again here. So I posted the Google Drive link so you can access the Google Drive link. And then regarding the homework, which Dr. City has already mentioned to you, it's here actually. For Kumamoto University students, you submit your report here. And this is, for example, group number 1 report, group number 2, 3, 4, and 5. So please make an effort to connect to your ITS group mates to make one report, all right? One report per group. And for today's lecture, Professor Aviso will talk about optimization. It's just a continuation of the lecture last week with optimization approaches. So here is the lecture material I got from Professor Aviso, and you will use this network optimization Excel file later during your exercise. All right, so I hope this is clear to everybody. You will be separated once again into groups later. You will have a group work once again, and it will be an opportunity for you to once again connect with your group mates, KU students connecting with ITS students, and vice versa. Okay, so I hope this is clear to everybody. Without much further ado, I will pass the virtual microphone to Dean K. Dean K. Yoroshiku onegaishimasu.
Thank you so much, Dr. Kitain. So hello, good afternoon, everyone. Nice to be seeing you again. So maybe I will also try to pick up from where we discussed last meeting and try to clarify some of the issues related to your group assignment. But before I do that, is it possible to ask one of the groups? Because last meeting, if I remember, there were 2 groups who gave a report on their products. Dr. Kitain, do you think we can ask them, or maybe just on October 22 when they submit their results?
Maybe we can volunteer.
Maybe just one group, either group 2, 3, or 4, who would want to share about the product that they decided to use last time. Any volunteers? So last meeting, I remember that we discussed about the solar panel. One of the groups was very comprehensive in their discussion of the solar panel. And the other group also mentioned that they are also exploring either the use of plastics, evaluating plastics, or also the use of solar panels. What about the other groups? I don't remember anymore the groupings. Maybe can we have somebody from group 3? Dr. Kitain, do you know the members of group 3?
Yes.
Yes. Can I share? Here you are. This is for group number 3.
Okay. Can we have somebody from group 3 to share with us what was the discussion last week among the group mates? Who is here?
We have Sakamoto-kun from Kumamoto University, Fukuda-san, and also, well, from ITS.
Yeah, don't be shy, just one. You can share with us. Dr. Kitain, maybe you can help me identify somebody who would be willing to present for the group.
From group number 3?
Yes.
All right.
Sorry, we didn't have to discuss, so we didn't decide yet.
Oh, but last meeting, we went into breakout session.
Yeah.
How was the discussion between the group?
About we talked about connect in online or yeah, something like that. So
Okay.
we couldn't do
All
this.
right. Okay, no problem. Maybe later we'll have more time for you guys to actually discuss with each other. Okay, thank you so much for that, group 3. So maybe I will just continue on. So I'll try to go through some of the slides that we missed last meeting, and then I'll go towards optimization. So just to explain further what your task would be for your assignment. So let me just share my screen. Okay, so let me just present it here. Okay, so just to refresh your memories and to guide you with your assignment. So the assignment is to figure out a product. So some of the groups have already identified the product. Maybe others are still discussing it. So it can be anything. And then the next one is to figure out the life cycle of the product or the supply chain. So essentially, all you need to do is think about these processes. So any life cycle will include the following processes. So raw material acquisition, processing, manufacturing, transportation, use, recycling, and waste management. But maybe it is not as simple as this one, because you need to you need to dismantle your product. Like, what are the components inside your product? And that will guide you in identifying your raw materials. What do you need for processing? Do you need transportation? Is there a way to reuse some of the items, or do you implement recycling? And how do you implement waste management? And when that is a bit clearer to you, then it might be possible for you to identify already what do you think are the requirements for each stage of the process. And then what do you expect as an environmental output for each part? So for example, last meeting, we had the solar panels, and actually the presentation last meeting touched upon a lot of these phases already. So it's a matter of organizing your thoughts and your ideas. So for example, to create a solar panel, what do you need? What items do you need? Do you need metals? Then you can include that in your raw material acquisition. And then you need to figure out, what do I need so I can get the metals or from mining? So you might need energy, or you might need fuel for your equipment. And what are the emissions from that particular phase? So you would probably have greenhouse gas emissions when you use energy, or you would have particulate emissions, because when you do some mining, you have to dig. So you can expect that there will be dust particles going out, and so on. So you just need to perform the process for each phase that you have identified. And it's okay if you don't put in everything, that's fine. So this is really just an exercise of recognizing what are the potential environmental impacts of any product that we use on a day-to-day basis. So I hope that helps clarify the assignment. Okay. All right. So let me just proceed, and then we can go on to optimization. So we've already discussed this last meeting. Okay, so these are the components of life cycle assessment. And in the same way, when you perform your analysis, you will also go through these particular steps. But for us, maybe we'll just end at inventory analysis, or identifying what are the relevant materials, energy streams, and environmental emissions. Okay, let me see. So for the goal and scope definition, it's very important that you will know why you're doing your life cycle assessment. So typically, when we do life cycle assessment, we do it to compare between product alternatives. For example, like one of the examples given last meeting, do you use paper bags or do you use plastic bags? So that's one example of why you do a life cycle assessment. It can also be just focused on one kind of product. So when you do life cycle assessment of solar panels, and what you want to identify would be which phase of solar panels would be the most environmentally hazardous. So is it the mining? Is it when you get raw materials? Is it the production process when you actually make the solar panels? Or is it when you use your solar panels once they have already been made? Okay, so that is what you need for goal and scope definition. So to do that, you also need to find out what your system boundaries are. What will you include in your analysis? Do you include everything? But if you do include everything, that will take a very, very long time. So you need to define up to where do you actually consider it. You have to identify the functional unit. It means that this is the purpose of your particular product. This is very important when you try to compare two different products because you want to compare them in a fair manner. So you want to see how they are able to provide the service that a customer will need. So if it's transportation, for example, you do not compare one car versus one train. Okay, so what you compare here would be the service that the vehicles can provide. So for that example, the functional unit might be the service to travel or to transport a person from one place to another, maybe a certain amount of distance. And that's an example of a functional unit. Okay, part of the goal and scope definition is also identifying what streams will you include. Do you include everything? Are you only concerned with global warming and greenhouse gases? Or do you want to include acidification? Do you want to include acid rains, for example? Or do you want to include air emissions, land emissions, and water emissions? So this is something that a decision maker needs to consider before doing the LCA. Because this will really guide you on further conducting the study. Okay, so this is just an example of a system. So this is a system that manufactures aluminum. And you can see here a red dashed line. It means that it is the system boundary for this particular system. So it means that the product of interest is the rolled aluminum and not the shaped cast and not the extruded aluminum. So you will only include all processes needed for the rolled aluminum and not the others. Okay. Okay. And now I know that companies are already starting to report their environmental impacts. So for companies, they need to consider different kinds of boundaries. So scope 1 would be the very direct emissions. So these are emissions actually generated in a company. But as we have seen, a company is just part of a supply chain. It is just part of the life cycle phase. It is not everything. Okay, there are other things that happen either before a company or after a particular once the product is already produced by a company. And that is where other streams come into play. So at the moment for reporting, they have separated electricity as scope 2. So it means that any indirect emissions coming out from electricity that is purchased by a company is included as scope 2. So it is indirect because you just get the electricity, but the production of electricity happens somewhere else. And the emission will depend on how clean the electricity grid is for a particular country. So if a country uses more coal, then you would have more greenhouse gases. If a country has more renewable items, then you would have less greenhouse gases. Okay? And then finally, for scope 3, this will include all other indirect impacts of a company. So this can include, for example, travel. So for example, your employees would need to travel somewhere to go to a conference. So that is an activity of the company, but the emission happens somewhere else, or it is carried by somewhere else. Okay, so those are indirect emissions. Okay, so I hope that gives a better picture of the supply chain and of the life cycle. Okay, so I think we've done that already. The next step is inventory analysis. Essentially, you just account. So once you've identified the flows that you need, or those that are important to you, all you need to do is to measure them. So how much energy do you actually use, and how much emissions do you actually produce? So now there are a lot of available softwares that actually just collect information, and they are a database. So they already have standard performance for certain types of industries, especially industries that are common in different countries. Okay, so yeah, so you can just make use of software. But if you want primary data, you can also get your data yourself. Again, it all depends on your objective or your intention. Okay, so this is just an example of how inventory analysis might look like. So you would have all the flows or all the streams that you are concerned with, and then the measurement, okay, for that particular stream. So you can just imagine how many items must be included in this particular inventory. That's why it's important to know the scope and the boundary of your analysis. Okay. So once you have your inventory, then you need to figure out how does each stream contribute to environmental impact. And this is where impact assessment comes in. So you need to classify the streams and figure out, where do they contribute? Do they contribute towards global warming? Do they contribute towards human toxicity? Do they contribute towards loss or reduction in resources? So that is what classification is all about. The next is characterization. What it does is just to make sure that you account for the contribution of each pollutant. It is similar to an exchange rate, like money, for example. Like my Philippine peso, how do I convert it to Japanese yen? So it's the same way. If you're talking about global warming, you want to know, if I emit carbon dioxide, how much global warming does that contribute? If I emit methane, how much global warming does that contribute? So sometimes they do not contribute equally. So some emissions might be more dangerous or more destructive than other types of pollutants. And then finally, there's valuation. And this is where decision makers come in. Because once you try to analyze different kinds of impacts, then you will need to figure out which impact is more important to you. Okay? So you want to see the total impact and overall assessment. Okay, so this is just an example. So these are some of the environmental impact categories that you can consider. And some people even go further and try to combine them into damage categories that are only limited to 4 categories. You have human health, ecosystems, climate change, and resources. Okay, and the footprints that we have discussed is an example of impact assessment, but they are limited to certain types of indicators. So we've already come across this. So I'm sure you've heard about all these different types of footprints. So you can have a look at my presentation so you can get a better idea of what they refer to. Okay. Okay, and then finally, once you have your results, then you can easily interpret and make decisions. So decisions can include, do you change your process? Do you change technologies? or maybe you select a different kind of product. But of course, the final interpretation should be linked to your goal or to your original objective. So the intention of doing the LCA is to answer your original question or your original dilemma. Okay, so that ends, I think, the LCA. Okay, just to continue on and going to our optimization and all. So these are the different aspects of practical aspects of conducting an LCA. So although it might be very tedious, like I mentioned, you need a lot of data. There are available databases that help the practitioner get the information that you need. So it really relies upon the user on figuring out how much detail or how much accuracy do you actually need so that you can make your decisions accordingly. Okay, so that's some people implement streamlined LCA to make it easier so that you can get results faster. But of course, you don't want to sacrifice the amount of information. So it's really a balance. How much effort do you need to spend for doing an LCA? And how much information do you actually get from your effort? Okay, so let me just continue. Okay, so we did this already. Okay, so maybe I will not delve too much into the case studies. Okay, so this is an example also of what you can do with your assignments. So you can group it like this. So this is like the supply chain or like the life cycle for making sandwiches. So the last product here is the sandwich in preparation. So the preparation, that is where you generate your sandwiches. But before you can do that, you also need other processes. So this will help you also identify what are the inputs and what are the environmental emissions. So this, maybe you can use this as a format for your assignment. Okay. All right, so let me just go on. So these are just sample case studies of how they have used life cycle assessment. So what are some practical implications? So now they are already using this perspective for analyzing various products and processes. It is also being applied for supply chains with particular focus on logistics, because you know that you need to transfer your products, and we know that our transport facilities will need fuel. And in the process, they will generate carbon emissions, because when you run your vehicle, it will burn fuel and it will, of course, generate various types of air emissions. So especially now that everything has gone online, there's a new trend, you know, you can customize products more easily. Production processes have become more flexible. And because of that, there was an increased demand for logistics and an increased demand for transferring goods and products. I'm not sure in Indonesia or in Japan how it is right now, but for me, for example, I now spend more because of trying to have my groceries delivered. So I buy something online for my groceries, so they deliver to me, but then I buy, for example, my clothes somewhere else, so they also deliver to me, instead of before that I go to the mall and I can just collect everything that I need in the mall and then go back home. So there's really an increase in transport and services. Okay, and so this is also an offshoot of this one. People are now really trying to improve the environmental impact of the supply chain. So it's a similar concept, it's a similar principle to life cycle assessment. But this time, you need to consider multiple stakeholders, because each company will be owned by somebody else. So you need to coordinate, and you need to make sure that you are all agreeing to improving your supply chain. Okay, so these are just some challenges. So like I mentioned, you have extended responsibilities, you have more stakeholders, but if you are successful in greening your supply chain, it can actually improve the company image, it can also improve business and operations performance, especially now that environmental issues are becoming more and more important. Okay, so these are some drivers that push companies to actually implement green supply chains. So it can be the demand from consumers, or it can be a push from government and other stakeholders. Okay, so in the Philippines, for example, we are our Securities and Exchange Commission is now requiring companies to report their environmental impact. So here are some indicators that they need to include in their company reports. So if you're applying or implementing LCA or life cycle or greening the supply chain, then it becomes easier also for the company to actually identify their performance. Okay, so let me just end with that. Okay, so just in summary, so we've looked at life cycle assessment and how it applies to greening the supply chain. So I hope that provides you a more holistic perspective on understanding the environmental impacts of different products and services and other processes, and understanding that emissions or environmental impact doesn't just happen in one place when you have a product, but it actually happens throughout its life cycle. So I'll end that one, but now we'll transition over to optimization. Okay, so I hope that was clear. So if there are any questions, so just type it in the chat box, or maybe we can discuss it later. Okay, so I'll just try to, so that we can have time for our activity. Okay, so now we've actually seen how environmental impact can happen when you have a product or when you have a service, and we've seen also some aspects of the supply chain. So now let's focus more on the biomass supply chain and how we can optimize it. So how do we actually optimize it? So when we say optimize, we want to make sure that everything is running efficiently. And whenever we optimize something, of course, we also need some indicators so that we know that we are doing our best in that particular aspect. Okay, so these are just this is just the outline of the presentation. So let me just focus more on biomass as a negative emission technology. If you will recall, last week we discussed about this, that to reduce carbon dioxide emissions, there are many strategies that we can do. And part of the role of biomass would be its contribution on negative emission technologies. And this is the production of biochar, which can be done when you pyrolyze your biomass. And so you separate the gas, which can be used for energy, and the biochar, which remains as a residual. And they have found that this biochar can be used as soil conditioner. So it means it can help improve the conditions of the soil and can even probably help plant growth. But of course, there are limitations. You cannot, anything too much, even if it's a good thing, is not so good. Okay, so this is one of the strategies wherein biomass can contribute towards reducing carbon dioxide emissions. So by generating biochar, you trap some of the carbon in that biomass, and it doesn't go back anymore into the atmosphere. So what happens is you get the carbon dioxide from the air when you grow the tree, but when you produce biochar, you keep the carbon in the biochar and then you put it in the soil. So it doesn't go back anymore to the atmosphere. And they saw that there is up to 130 gigatons potential for negative carbon emissions when we implement different types of, when we implement biochar. Okay, so here are just some advantages and disadvantages. So there are different kinds of negative emission technologies. A good thing about biochar, I think, it's really relatively a mature technology. It's already being used, but not at a very, very big scale. So if we want to have significant reductions in carbon dioxide reduction, we need to make this implementation bigger or on a wider scale. And that is why we proposed a planning tool. How can we manage our biomass? So if you want to read more details about this work, you can refer to our articles. So wherein we use different techniques on how to optimize carbon management networks. So like I mentioned, once you have biochar, you can put it as soil conditioner. So what exactly is a carbon management network? It means that you need to plan out well how you will generate the biochar. So what is the source? Which plant which plant do you generate it from? And where do you actually apply it? And of course, if you make it travel, like if you transport your biochar from its origin to its destination, then that will require transport, and it will also generate carbon dioxide. So what happens is you might not actually bring down carbon dioxide when you try to transport it in a very, very far location. So you have to make sure that the place where you put your biochar in will not offset the benefits that you get when you actually produce your biochar. Okay, so this is another one that we did. So there are several layers wherein you have your biomass. You use biomass co-firing. I think we discussed that last meeting. And when you produce your biochar, you need to figure out where you actually put them afterwards. Okay, so this is the problem that we tried to solve using optimization. So if we know we already have biomass and we know we have existing power plants, where will the power plant get its biomass from? And then once it generates the biochar, where do you put it afterwards? Okay, and optimization can help us identify the most efficient pathway to actually do this so that we can maximize the reduction in carbon dioxide. Okay, so before we move on to our optimization, so let's have a bit of introduction. I'm not sure what program you are in, but I think you're in STEM. So I think this is integral in any kind of STEM discipline, especially if you plan to take up engineering. Because as engineers, we always want things to perform well or perform at its best. So that is why we need optimization. So in the field of chemical engineering, there is a document that goes way back to 1956 on how optimization can be used for designing different kinds of processing plants. Okay, so these are just some books of chemical engineering. So these are textbooks that actually look into optimization. And these are some of the applications of optimization in engineering. Okay, so my field is in process systems engineering, and it's related to computer aid, or also referred to as computer aided process engineering. And this is the kind of work that we do. We develop optimization models when we try to design a particular system. So we know what is the best way to operate it, or what is the best way to design a particular system. And so just to give you a brief overview of how optimization works, so it goes beyond maybe what you've learned in calculus, wherein you take the first derivative. So it's somehow related to that. But now there are a lot of softwares available wherein you can actually write in your equations, and then it will help you identify the best way. So hopefully we can do that today just by using Microsoft Excel. So I hope everyone has access to Microsoft Excel. So any optimization model is defined in this way. You will always have an objective function. So objective means it is the indicator that you want to minimize or you want to maximize. Okay. Then we have different kinds of constraints. So these are the boundaries. So like how can you operate your system? Of course, there are limitations. So this can be limitations in budget, for example, which would be an inequality constraint. It can be satisfying mass and energy balances. then that would be your equality constraint. And then you might have continuous variables such as temperature, pressure, or you might have integer variables, which might represent choices. So do you choose this technology or this technology? Or they might be in the form of like number of stages when we're talking about chemical processing plants. Okay, so these are some details or other further explanation of the different components in optimization. And there are different kinds of models. So it really depends on the type of equations or type of constraints that you have in your models. These can be linear programs when all your constraints or all your representations are linear in form. So it means that the exponents of your unknown variables are all having exponent of 1. So that's a linear program. But if the exponent is different from 1, maybe it's a fraction, you have a square root, or maybe a square, a logarithmic function, then it becomes a nonlinear program. Okay? So other things that differentiate the type of model would be the type of variable available. So do you have continuous variables such as temperature, time, pressure, or do you have integer variables such as counting numbers, maybe logical yes or no conditions? So if you just have continuous, then you have a linear program or a nonlinear program. If you only have integer values, then you have an integer linear program or an integer nonlinear program. But if you have a mix of these two, then it becomes a mixed integer linear program or a mixed integer nonlinear program. Okay, so it really depends. So this is just to help you visualize. So whenever you have a linear program, you can actually plot the different constraints that you might have in your problem. And it might look something like this. Okay, it really depends on how many unknown variables that you have. So for this case, maybe just 3 unknown variables because we have a 3-dimensional space. And you can see that the slope is continuous. So it's like a linear form. So it's very easy to figure out where the maximum is and where the minimum is. So it's like when you drop a ball onto it, it will go towards the lowest section of your linear model. So that is why it's much easier to solve linear models, because our algorithms can easily detect where the lowest point or the highest point is simply just by checking the slope and whether you are getting improvements in your performance when you move from one direction to the next. Okay, so that's easy to solve. The problem comes when you have nonlinear programs, because the surface of your problem or the region where the solution might be might look like a curve, just like this one. Okay, and if you throw a ball, it might lie on saddle points, such as this one, which is not the true minimum or not the true maximum of your problem. So that's one of the challenges for nonlinear programs. And although there are powerful solvers now, I think it really depends on the problem that you have. I know that a lot of researchers are still struggling when their problem becomes very, very big and becomes nonlinear. It takes days to actually solve, and sometimes just a few adjustments, you do not even get a solution. So that's the problem for nonlinear models. Okay, so why is it important to actually make models? So making models are intended to approximate a real system. So we do this, especially if we do not have enough resources to keep on performing experiments, or when a particular situation cannot be done in reality. Like, for example, if you build a processing plant, you can't just guess how big a processing plant should be and then find out that it's gonna fail. So what we do is to create models so we can have a computer representation of the real system. And by doing that, we get to see how a system would behave if you make certain changes in its conditions. But of course, we will always need to balance model fidelity, like how closely does it represent the real scenario or the real system, and model computability. How fast do you actually get solutions? Because we can imagine that real systems are very, very complex and would be represented by nonlinear models. But even though it's very close to the real system, but you can't compute it, then you still won't get a solution. So what you want is to find that balance so that the model can provide enough insights to decision makers to make sound decisions. Okay, so now let's look at one of the classic models for optimization. So these are transportation models, which are very useful also for examining supply chains. So transportation model was developed by Leonid Kantorovich, and he actually won the Nobel Prize for it. So what he did was to figure out a way for optimizing the allocation of resources, which I think is still very relevant to us today. So if we don't have enough resources, but it has to be used up by a lot of people, what is the correct way of doing that? So that can be modeled similar to a transportation model. And so this is the basic problem structure. We have resources, and these are the users of the resource. The question is, where does each resource go? So this is what we call the superstructure. It means that there are multiple different ways of connecting the sources from the sinks. And the model will try to figure out what are the correct connections. So these are just the equations. We'll go through them and try to do it in Excel. So essentially, what we want is to minimize cost. And we should have the following information. How much does it take to transfer materials from one place to the next? What is our available resource? And what is the requirement on the demand? What the model will figure out is how much will be transported from one place to the next. Okay, so we want to minimize cost. What is the right pathway to do it? And we need to satisfy the following conditions. Of course, if we only have so much resources, then we should operate within those constraints. We cannot give more than what is available. So this is what this equation mentions. Of course, each demand should be satisfied. And then finally, okay, so we can also make use of inequalities depending on the condition of our situation. So for example, the sources can be just like budgets, cannot be exceeded. And then finally, since these are flow rates, they cannot be negative. Okay, so let us go. Okay, maybe no need to consider this. Okay, so let us go to an illustrative case study, which I will demonstrate to you. And then later on in the worksheet that I gave you, there is an extended case study, which you can actually perform in your individual groups. Okay, I think I'm taking so much time. All right, let me stop this. Okay, let me just go and look for my Excel file. Okay. So I hope you're still with me. All right, so you need a special add-on in Excel to be able to perform optimization. So I will demonstrate to you guys how we can do the add-on. Okay, so there, so Dr. Seti has shared with us the Excel file in the chat. Okay. So the tool that we will use is Excel Solver, which should be found in the data section. Here, Solver. If you do not have it, it means you have to activate the add-on. So you go to File, then you go to More, go to Options, go to Add-ins, and then click Go. And then Solver will tell you what are the available add-ins in your Excel. So there should be Solver add-ins. Okay, then just press OK. Okay, so I hope everybody got that one. Okay, let me just remove everything so that we can go through it step by step. All right, so this is the same problem that we have. We have available sources. This is the amount available. Then we have demand. How much does each region need? And then we have cost matrix. It means how much does it cost to get from one place to the next? Okay, and then we have here a total cost, and then we will put here our objective function. Objective function. Okay. Okay, I will create a matrix here first to show you how to calculate the cost for each time you transfer. Okay, so let's put a hypothetical scenario. So for example, this is how so we don't know yet if this is the best way to do it, but how much is it? Okay, so this is one solution to our problem. So I will just add here, add through the rows. So add 400 and 600. So I get 1 million. So I do the same. Okay, and then I add the columns. So sum, just drag. Okay, there. So this is one solution to our problem, wherein we satisfy the demand and we are able to distribute without exceeding the limitations of our sources. Okay, so but how much does that cost? So we can create a matrix here to add how much does it take to transfer from one place to the next. And I will just multiply the cost by the amount transferred. Okay, so this is the amount to transfer 400,000 tons from source one to demand one. Okay, so we can just do that, copy, and I will just paste it here. The same principle, function. Oh, hold on. I'm sorry. I only have two. Okay, paste function. Sorry, I do not have third column. Only two demands. So now we already have total cost. I will put it here. It is just the sum of this one. Okay. Okay, so that is our total cost. Our goal is to minimize the cost. Is there a better way to actually do this? So I will put it here as our objective function. So equal to the total cost. And then I will go to solver. So I go to data, go to solver. Okay, this is our objective. So our objective is to minimize cost. So I will click this and then just put it here. Okay, so you have a choice. Do you want to maximize? Do you want to minimize? Next, changing variable cells. It means this is what the model can change So I will highlight the yellow part because we did this only by guessing, but we don't know if it's the correct one. But Solver will help us figure out what is the correct one. And what are my constraints? My constraints are, I want this one to be less than what is available, making sure that I do not exceed what is there. And then I want the distribution to be equal to what is actually needed. Okay? All right. So I hope you take a screenshot or try to memorize the initial solution, and let's see if there's a better solution. So initially it's 256 million. If we solve, did it change? Okay, it changed. So it actually found a better solution. So it reduced the total cost to 200 million. And this is how the distribution should be. Source 1 delivers to 1 and 2, but demand 2 gets more from source 2 and source 3. So demand 1 doesn't get any additional. Yeah, just from source 1. Okay. So yeah, that's the optimization. I'm not sure, do we still have time, Dr. Kitai? Because it's already 12:50.
Would you like the students to try it?
Yes, okay. Yeah. I just want to know if the students were able to follow me.
Right. Okay.
Okay. If not, maybe we can do okay. Have a look at the solution. Maybe we can do a breakout, and then see if you can get the same solution as what I did.
All right.
Okay.
Let's try. So I'm going to divide them into 5 groups according to your group assignments. So please go to your respective group number. So 5 groups, everybody. Let participants choose room. So please go to your respective room or group number. Okay. So go ahead now.
Okay. How many minutes do they have, Dr. Kitain?
We have actually 35 minutes left.
Okay. All right. Good.
We can give them around 20 minutes. Also.
All right. Perfect.
Okay.
Perfect.
Okay. So students, you have 20 minutes to work on your assignment.
Okay. Good.
Use the Excel file. All right. Try to.
Okay. Maybe we can do an extension. Do you think we can do an extension because there's another worksheet, or they can try to replicate the one. Okay, they can replicate that one, and they can also try out the one in network 3 here.
Oh yeah.
Which has more demands and more sources.
They can work on the duplication.
Okay.
And then probably if they still have
time. If you still have time, yeah, you can explore network 3.
Network 3, yes. Okay.
All right. Good.
Okay, okay. Probably we can give our students 20 minutes to work on it. Okay. Thank you so much. Please go to your respective rooms.
Yeah, unless you have questions before going to your rooms.
Right. It's also an opportunity for our students to connect while discussing
yes.
the problems. Okay. Right. So for students sitting in or auditing the class, you may join any group that you like.
Yeah.
All right.
Do you have a lot of audit students?
Yes, from Kilpacorn University, Chulalongkorn University, and UTP, University of Technology. So maybe around 10 students, right? If I'm not mistaken, around 10 students.
Yeah, hopefully next time we'll get more DLSU students.
Oh, yeah.
Yeah, it's just that
I look
it's
forward to it.
term break. Yeah, we're starting our class on Monday.
I think Habib, Saga, and Rifki, they have a Friday prayer, but
Okay.
they're attending this.
Yeah. Five, four, three, two, one. Okay. Only two from group number one.
Oh.
Maybe they're having Friday prayer. Group number two is okay. We also have one Japanese student. Group number three, two Japanese students and two ITS students. Number four, we have also one Japanese students. Number five, good, well represented. So they will, anyway, they will also exchange line accounts later because they need to work on group homework. They need to submit October 22nd.
Oh, yeah.
Yep.
How is it in Indonesia, Doc City? Is there any, are you going back to normal already? Not yet.
We still have hybrid in Aviso. So just a student from, I think, the 2020. So I think the fresh grad, something like that. The first year. As long as they have like permission from their parents, so they can attend for hybrid class.
Okay, when will you have hybrid class?
Starting 2 weeks ago.
Oh, okay.
Yes.
Wow.
So we change our class become like smart class.
I see.
In Kumamoto, we will start our in-person or face-to-face classes November 4th. Especially in the Faculty of Engineering, they have an announcement already.
This is full face-to-face, no hybrid, or
face-to-face.
Wow. So how is the how many people are allowed? Will there be limitations? Or?
There are big classes where they're considering it also. Like they might separate them into two classrooms. Especially for big classes. Like we have also like 100 students in a class. So in that case, it'll be separated into two rooms. Something like
for
that.
senior high school till to kindergarten, they start already for face-to-face class. But how to say, the quota is only 25%.
25%. I see.
Yes, 25%.
25% of the classroom capacity.
Yes, for the classroom capacity. So if how to say, they will observe if there's nothing happen, for example, like that, no COVID increase, etc. So they will increase to 50%.
But do you require everyone to take the vaccine or no need?
Yes, in ITS.
Required.
Yes.
Oh, okay.
To be fully vaccinated.
Yeah.
That the requirement should be fully vaccinated, and then second, they have like get permission for the parents.
What if the parents don't allow? What do they do?
It's okay. They can do by online.
Okay. But
it's hybrid. I see.
Yeah, hybrid. But for the hybrid, like, do they go to class at the same time? Except
yes,
that,
the same time. So that's why it's quite difficult, because if you have hybrid, you give more attention to the student attend the class, not the online.
Yeah. But what about the exams? Like the same? Like you give exams at the same time? or a different schedule?
Not yet, not yet. I don't
Something
know.
to think about.
But if I ask students, oh, they say, Mom, better for exam, do by online. But for class, offline.
For the exams, what do you use for checking? What portal? What LMS?
Similar with Kumamoto, we use a Moodle.
Moodle.
So we can,
okay.
yes. But the name is like My ITS Classroom, something like that. That's the name.
Okay.
Same as Moodle. So we can do assignment, we can make anything.
I see.
Right. The one I shared a while ago didn't came. So that's Moodle actually. Materials, announcements, instructions to Moodle.
Okay.
And even submission of reports. Reports, projects.
But for the exam, do you do it like cams on like that? Do you do it like that?
For exam, in my case, I don't give like written. So I ask just.
But some might call it really
presentation and reports. Yeah.
Okay. Yes.
And then they have like limitation time. So for first problem, they give only 10 minutes. After that, after 10 minutes, they open another problem. Next, something like that.
So there's a problem actually giving, like exam also for those faculty members having these language classes. Yeah, that's a challenge actually giving final examination, especially it's a language. So like German.
But reports are okay, I think.
Reports are okay. They cannot cheat.
Yeah, they cannot cheat. Yeah. The problem I think would be some courses that aren't really designed for reporting. Like, the very basic ones, like calculus. Like, you need to know how to calculate.
Right. Even problems. So, if you give them problems, there are so many possibilities for cheating.
True. It's a challenge. And how are your students coping up with the situation? Has there been increased, incidences of depression or something like that?
Yeah.
Oh, just before I came here, I was in another meeting. It was organized by our Office of Counseling Services, something like that. So they were giving a webinar on how to detect and how to address if the situation something.
Mental problems.
Yeah. We have a lot. Plus, some of the students, when a family member gets sick, they're the ones taking care of
their
parents.
That's also the situation here, especially for elementary, high school students. So many depressions, even so many cases of suicides.
Yeah. I think here as well.
Here in Japan, That's another thing that we also need to consider. That's why we don't give much.
Yeah, true. Because the pressure and the stress level.
We're taking so many classes also.
Yeah.
Online. And they don't have much opportunities for them to talk with their friends.
Yeah. Especially the new students.
The first year and second year students.
Because they don't know anyone yet. Maybe they came in from a different school and
that's right. That's the dilemma. That's a problem.
But how is how are the hospitals going on like now? Are they in full capacity or not so much anymore?
In Indonesia, no, not so much.
Okay, that's good.
Yesterday we only have like one new case.
Okay, that's good.
Yeah, I think.
I think the cases are already declining now. I think yesterday we had about 8,000.
I see.
But
They
that's
have,
already declining.
right. So still online classes in Manila.
Yes, and yeah, we're still all work from home.
I see.
Yeah, I haven't gone out for so long.
Really? Oh yeah.
Yeah, well, except for you know, things like going to the bank and
Mm,
groceries. I do delivery. Food, we
Oh,
just cook at home. Yeah. So,
only for essential things, right?
every week I still go to local market.
I
In
used to do
Aviso.
that. Yeah, I used
Yeah.
to do that during the earlier days because
Mm.
deliveries were not so reliable before, but now they're very good. So
They're very
I
good,
get lazy.
even in Indonesia.
You have
Like
the
my sister, everything online.
Yeah, true.
Buy ruler,
I see.
Yeah, buy medicines online.
bean sprout, everything. Oh,
Yeah. Plus, you know, the situation always changes. Like it's good this week, next week, not again. So
Yeah.
every now and then
Very,
there's a
very
change.
unstable. Yeah.
Yeah, there's a change in policy.
in
Sometimes you're
Indonesia,
allowed.
they differentiate by level. So if you are already in the level 1, so it means you can work from office more than 25%. If you are already in the level 2, level 3, level 4, something like that. If level 4, it means you're not allowed to go to office. It means 100% should be work from home. So
Yeah.
each area will be different.
True. And then, yes, so many restrictions. Like you can't go to this, you know, even if it's just, you know, very close by, but it's a different
Yeah.
city already. You can't pass.
Yes.
Mhm.
But in Surabaya, mall are open all. But you have to show your vaccinated
Okay.
card, something like that.
So you have that card also.
Yes.
Okay.
Yeah.
So it's become a very important thing right now.
So
Otherwise, you're not allowed to.
that's good. That's good.
I think the Philippines allow tourists fully vaccinated to enter.
I saw there was a report that you don't need to quarantine anymore if you're coming from a green country, something like that. They have a list. Yeah, they have a list of countries that they consider green. But people were commenting like, but nobody goes to those countries. I think like North Korea, like if you're coming from North Korea, you don't need to quarantine. If you're coming from Cameroon, no need. It's like, okay, but you don't go to those countries.
Room 1. Why room 1 right now only Natsumi and stuff?
Yeah,
Wait a minute, let me check again.
One left, all right.
Oh yeah, only one.
Wait a minute.
For Natsumi.
Okay. Oh, I think Brilliant already
ask for help.
joined. Wait a minute.
Recording stopped. Recording in progress.
Yeah, a member from group number 1 left for the prayer. So okay, so we now have Matsusita-san.
Yes, because all the how to say, sorry, for ITS member, I think there's a girl, but no. So all is are male students, so they have like Friday prayer. Because actually I already, for example, in group 2 already there is a female. In group 3 there is a female student. Group 4 female student, and group 5 there is a female student. But I'm forgetting the group 1.
It's okay.
All are male students, so they will have Friday prayer. Oh.
Problem.
Okay.
But it's all right, Dr. City. It gave Natsumi, Matsuita-san, an opportunity to connect via line so they can work.
Okay.
Okay,
Thank you. Forget to consider that one, Natsumi.
Yeah, no problem.
But you already contact with ITS students?
Yeah.
Yes.
Okay, good.
All right. So I think one more minute. I'm going to close the room, and they're going to go back to the main room in 1 to 2 minutes. Okay.
Because usually Intan from UTP will join to group 1, but I think they have like some problem because since before like connecting to audio.
I see.
Excuse me, ma'am.
Okay, Rifki.
Sorry, I just come back from prayer.
Okay. I forget that all I put all male student in the group 1. Forget to put female student.
Yeah, ma'am. In group 1 is male.
Yes. Okay, it's okay. But as you contact after class, it's okay.
Then Kay, probably later you can ask 1 or 2 groups to discuss what they did in the breakout room. All right.
Yep.
Okay, so welcome back to the main room, everybody. So here again.
Okay,
Dean
thank you.
K.
So I hope that you guys were able to discuss. So can we request some of the groups to show us or share with us what happened during your discussion? Maybe group 4. Dr. Kitain, who's from group 4? There we go.
All right. Rafida, go ahead, Rafida, please.
Yes, hello, I'm from group 4. I'm going to try to share screen what we got, but please correct us if we have any mistakes.
No problem.
All right. But we haven't finished trying the network 3, so I'm going to start with network 1 and 2 first. So for network 1 and 2, so what we did is we guessed first the yellow boxes. We guessed and then we calculated for the cost metrics here by multiplying the demand and also the cost metrics. And then we calculated the cost from the sum here. And afterwards, what we did was we used solver over here to calculate the minimum cost we could get. So that's what we did for this one. For the network 2, we did the same thing. we guessed the yellow boxes, and then we calculated this one, and then we got the guess total cost, and then when we solved it, this is how much we got: 176,000 million. So that's from group 4.
That sounds good. Yeah, maybe I have a question. Were there things that were like difficult, or did you have any challenges while doing it?
We were trying to figure out, because we kind of forgot what we had to do on this part. So we were guessing, oh, probably we should multiply the demand with the cost matrix and so on and so forth. But that's what we get from there. So that's the challenge we got.
Okay, but you managed to overcome the challenge.
Yes, thankfully, yes.
Okay, looks good. Very good. That was really good work.
Let me stop my share screen. Thank you very much.
And then finally, group 2. I think it's, yeah, the only remaining group who hasn't shared yet.
Yes. So we decided what will we do until next Friday. I think we should submit some report, and we decided the process of making clothes by polyester fiber, and this process, yeah, and we discussed about that.
Oh, okay.
A little bit, yeah.
Yeah, so, we're sorry that our group really haven't really touched the Excel yet, because we discussed about the previous assignment. Regarding
no problem.
yeah, because last week Atsiri wasn't joining us, so we
Okay.
So we had the opportunity to discuss about the assignment
that's good.
this week. So yeah.
Okay, that's good. I hope you managed to settle some things for your assignment. Were you able to identify your product? Sorry, I think I might have missed it.
We decided on polyester clothing, usually used for sports clothing. Yeah.
Okay.
So we decided to break down about that.
Okay, sounds interesting. Okay, so I hope you'll have, I'm sure you'll have interesting results for your assignment.
Yep. Thank you, Professor Aviso.
Okay, thank you so much. And I do hope that all the other groups manage to do either do the Excel file. If not, that's fine. You can also do it on your free time, on your spare time. Just explore it a bit, so that you at least know what other capabilities there are in Excel, and that these kinds of calculations can actually be done easily. Of course, it gets more complicated if you try and add additional layers into your system. Okay, let me just continue on. I think we still have about 10 minutes, right? Okay, so let me just continue on how we can further expand. So thank you for group 4 that you managed to go through networks 1 and 2. Okay, so good. All right, so the next one would be, I'm not sure if you asked the question on how does it relate to environmental impact. Okay, now I will answer that question, whether you asked it or not. All right, so the model that we did can actually be extended also to account for environmental impact. So we've been talking about how transportation can actually have emissions, and that we want to reduce those emissions. So for our first step, what we did was to minimize cost, which is something that is of concern to companies. But if you want to be greener, your next concern would be your environmental impact. And you can do a similar calculation just by creating another kind of matrix. So instead of a cost matrix, we now make use of a footprint matrix. It means that it accounts for the carbon footprint whenever you try to transfer one material from one place to the next. So because the lowest cost might not necessarily be the same solution as the lowest environmental footprint. So let's try this out. So I now have a footprint matrix here. And the footprint matrix, you can get the information in a similar process as LCA, wherein you do an inventory of that particular process. So if you have vehicle and you know that it's running on a certain type of fuel, and when you burn that fuel, you know that it's generating carbon dioxide and other types of emissions. So you can easily calculate how much fuel do you burn when you transport material from one place to the next. Okay, so you can get that information. So we will treat it just like our cost matrix. So I will just multiply also. So footprint multiplied by the amount of materials being transported. Okay, and I will just copy that one again and fill out all the other there. Okay, so obviously this becomes 0 because we're not transporting anything from source 2 to demand 1 and source 3 to demand 1. And so we can again get the total footprint by getting the sum of all those elements. Control Shift. Enter that. Okay, enter. Sum enter. Sorry. We just changed that. Okay. All right. So let me just copy this information just so we know the results of minimizing the cost. Okay. So this is how it looks like when we're minimizing the cost. Just fill those up. All right. And so now we will do the optimization again. But this time, instead of trying to minimize the cost, okay, wait, I'll copy this one first. So this is the footprint for minimizing cost. So footprint. Let me just put here. Oops, sorry. Copy again. Copy. So footprint. And then, right? And then cost. This one. Just put it here. All right, and now I will perform the optimization again. But instead of minimizing cost, I will minimize my footprint. So that becomes my objective function. So I put it here, footprint. And then I go back to data solver. So no need to change because we just changed the contents of D9 already. So it's the same. So now we solve and see, okay, there. And see, I'm not sure if you noticed, but now we have a different solutions. Maybe if I reduce it, we can see both solutions in the screen. So see, so this one on the right is our solution when we did minimizing of cost. And now this one is our solution when we did minimizing of carbon footprint. And you can see that the total footprint is less. It's just 14,400,000. But the total cost for this reduced footprint is more. So it's 224. So it's a bit more than the optimal solution for cost. And so I hope this shows you, or this demonstrates how there can be multiple objectives in a given problem. And so as a decision maker, you need to balance or try to figure out how you will balance this kind of information. So do you go for minimizing cost, or will you go for minimizing footprint? Or will you go for something in between the two? Okay, so that really is upon depending on the decision maker. Okay, so I hope you get that one. And so now let me just go back to my presentation. So all the steps I've already included, all the other details, information can be found in this Excel, in this PowerPoint slide. And so let's go on to our conclusions. So I hope that you've seen how a classical transportation model can be used for optimizing supply networks or supply chain networks, and how these transportation models can actually be extended to incorporate some environmental aspects. And so you can actually make your model identify the network that will have the best environmental impact. And so you can use it if you want to green your supply chain, or if you want to improve your carbon management networks. We just did a very simple example here, but it's a similar case for carbon management networks. For carbon management networks, you can account for the amount of carbon that is sequestered or removed when you place biochar from one location to a particular location. And so you can easily do this linear program just by using Excel. But of course, if you want more complexities, you can always add it into your model, but you can expect that it will become more complex, of course. All right, so what other things can we look into in the future? So these models can actually be integrated, hopefully, into other big data platforms, especially now that we have a lot of information coming in, and a lot of the decisions that we make are also linked with availability of data. So for example, you can have trucks that will have GPS devices that can clearly, accurately track what is the distance being traveled or how many emissions can be generated. You can also include some form of uncertainties to have decisions that are more informed, or at least consider what are the uncertainties in your system. Okay, so you can integrate also economic policies. Maybe there is an incentive if you try to improve your environmental impact. And biochar carbon management networks can actually also be integrated with other negative emission technologies. All right, so let me end with that. So thank you so much. If you do have any questions, please feel free to ask or get in touch with me.
Thank you so much, Dr. Dean Kay, for sharing your expertise on environmental issues and optimization, LCA analysis in relation to biomass utilization. So thank you very much. So I will keep in touch, Dean Kay. And to our students, of course, we would like to thank you for being so cooperative, and please continue connecting with your newfound friends, okay? KU students, ITS students, and vice versa. All right. So once again, thank you very much, Dean Kay. Dr. Siti, do you have any announcement or something to say before we end the class? Yeah.
I think quite similar, Prof. Kitain. Please contact your group mates to discuss your group homework. You can discuss beyond the group homework. Once again, thank you so much, Dean Kay, for an interesting talk. Thank you so much. Okay.
Next week, Dean Kay, thank you so much once again. Next week, we'll have Professor Dr. Susanna Yusuf from the University of Technology, Petronas, to talk about conversion technologies. So you see you once again. See you next week, Dean Kay. Thank you so much. I'll keep in touch.
Bye, guys.
Okay, bye. Thank you. Goodbye.
Thank you so much, Professor Kitain.
Dr. Siti, thank you.
Bye.
I'll keep in touch. Bye-bye. Bye-bye.
Recording